The moon is our closest neighbor, but how well do we know this neighbor? Learning about the moon can teach you about Earth. Hi, and welcome back. In today's science episode, I will talk about the moon, Earth satellite.
The Moon, Earth's satellite. Motions of the Moon. Just as Earth rotates on its axis and revolves around the Sun, the Moon rotates on its axis and revolves around Earth. The Moon's revolution around Earth is responsible for the changes in its appearance. In the Moon, if the Moon rotates on its axis, why can you see it spin around in space? The reason is that the Moon's rotation takes 27.3 days, the same amount of time it takes to revolve once around Earth. Because these two motions take the same amount of time, the same side of the Moon always faces Earth, as shown in Figure 5. Reflection of the Sun. The Moon seems to shine because its surface reflects sunlight. Just as half of Earth experiences day as the other half experiences night, half of the Moon is lighted while the other half is dark. As the Moon revolves around Earth, you see different portions of its lighted side, causing the Moon's appearance to change. And here, you can see a different photograph that shows what we call the phases of the Moon. The phases of the Moon change during a cycle that lasts about 29.5 days. Waxing phases. After a new moon, the phases begin waxing. Waxing means that more of the illuminated half of the moon can be seen each night. About 24 hours after a new moon, you can see a thin slice of the moon. This phase is called the waxing crescent. About a week after a new moon, you can see half of the lighted side of the moon, or 1/4 of the moon's surface. This is the first quarter phase. The phases continue to wax. When more than 1/4 is visible, it is called waxing gibbous, after the Latin word for humpback. A full moon occurs when all the moon's surface facing Earth reflects light. Waning phases. After a full moon, the phases are said to be waning. When the moon's phases are waning, you see less of its illuminated half each night. Waning gibbous begins just after a full moon. When you can see only half of the lighted side, it is the third quarter phase. The moon continues to appear to shrink. Waning crescent occurs just before another new moon. Once again, you can see only a small slice of the moon. It takes about 29.5 days for the moon to complete its cycles of phases. Recall that it takes about 27.3 days for the moon to revolve around Earth. The discrepancy between these two numbers is due to Earth's revolution. The roughly 2 extra days are what it takes for the Sun, Earth, and Moon to return to their same relative positions. Eclipses. Imagine living 10,000 years ago. You are foraging for nuts and fruit, and unexpectedly the sun disappears from the sky. The darkness lasts only a short time, and the sun soon returns to full brightness. You know something strange has happened, but you don't know why. It will be almost 8,000 years before anyone can explain what you experienced. The event just described was a total eclipse, as shown in Figure 7. Today, most people know what causes such eclipses, but without this knowledge, they would have been terrifying events. During a solar eclipse, many animals act as if it's nighttime. Cows return to their barns and chickens go to sleep. What causes the day to become night and then change back into day? What causes an eclipse? The revolution of the moon causes eclipses. Eclipses occur when Earth or the Moon temporarily blocks the Sun from reaching the other. Sometimes during a new moon, the moon's shadow falls on Earth and causes a solar eclipse. During a full moon, Earth's shadow can be cast on the moon, resulting in a lunar eclipse. An eclipse can occur only when the Sun, the Moon, and the Earth are lined up perfectly. Because the Moon's orbit is not in the same plane as Earth's orbit around the Sun, lunar eclipses occur only a few times each year. Eclipses of the Sun. A solar eclipse occurs when the Moon moves directly between the Sun and Earth and casts its shadow over part of Earth, as seen in Figure 8. Depending on where you are on Earth, you may experience a total eclipse or a partial eclipse. The darkest portion of the Moon's shadow is called the umbra. A person standing within the umbra experiences a total solar eclipse. During a total solar eclipse, the only visible portion of the Sun is purely white glow around the edge of the eclipsing Moon. Surrounding the umbra is a lighter shadow on Earth's surface called the penumbra. Persons standing in the penumbra experience a partial solar eclipse. Warning: regardless of which eclipse you view, never look directly at the Sun. The light can permanently damage your eyes. Eclipses of the Moon. When Earth's shadows falls on the Moon, a lunar eclipse occurs. A lunar eclipse begins when the Moon moves into Earth's penumbra. As the Moon continues to move, it enters Earth's umbra and you see a curved shadow on the Moon's surface, as shown as Figure 9. Upon moving completely into Earth's umbra, as shown in Figure 10, the Moon goes dark, signaling that a total lunar eclipse has occurred. Sometimes, sunlight bent through Earth's atmosphere causing the eclipse moon to appear red. A partial lunar eclipse occurs when only a portion of the Moon moves in Earth's umbra. The remainder of the Moon is in Earth's penumbra, and therefore receives some direct sunlight. A penumbra lunar eclipse occurs when the Moon is totally within Earth's penumbra. A total lunar eclipse can be seen by anyone on the nighttime side of Earth where the Moon is not hidden by clouds. In contrast, only a few people get to witness a solar eclipse. Only those people in the small region where the Moon's umbra strikes Earth can witness one. The Moon's surface. When you look at the Moon as shown in Figure 12, on the next page you can see many depressions called craters, meteorites, asteroids, and comets striking on the Moon's surface, creating most of these craters which formed early in the Moon's history. Upon impact, cracks may have formed in the Moon's crust, allowing lava to reach the surface and fill up the large craters. The resulting dark flat regions are called maria. The igneous rocks of the maria are 3 billion or to 4 billion years old. So far, they are the youngest rocks to be found on the Moon. This indicates that craters formed after the Moon's surface originally cooled. The maria formed early enough in the Moon's history that molten material still remained in the Moon's interior. The Moon once must have been as geological active as Earth is today. Before the Moon cooled to the current condition, the interior separated into distinct layers. Inside the Moon. Earthquakes allow scientists to learn about Earth's interior. In a similar way, scientists use instruments as the one shown in Figure 11 to study moonquakes. The data they have received have led to the construction of several models of the Moon's interior. One such model is shown in Figure 11 suggests that the Moon's crust is about 60 kilometers thick on the side facing Earth. On the far side, it is thought to be about 150 kilometers thick. Under the crust, a solid mantle may extend to a depth of 1,000 kilometers. A partly molten zone of the mantle may extend even further down. Below this mantle may lie a solid iron-rich core.